What's up, scholars? Today we're talking about the Pythagorean theorem and distance formula, and I'm going to show you how very closely related they are. Okay, first, let's remind ourselves, what is the Pythagorean theorem? The Pythagorean theorem comes to us from the famous geometer Pythagoras. It says, of course, that a squared plus b squared is equal to c squared in a right triangle. So let's draw ourselves a right triangle, meaning it has one right angle. The c side is always the hypotenuse. It's always the longest side. It's always across from the right angle. And then the A and B sides are either one. That could be A or that could be B. It doesn't matter. So let's do A and B. Let's do an example with the Pythagorean theorem. I'm going to get a new color because that's what I'm going to do. Alright, so an example of said Pythagorean theorem. Let's do... I'm going to draw in a different orientation. This will not be to scale really at all. Okay, let's do, this side will be 6, this side will be 8, and let's solve for the hypotenuse. We'll solve for the hypotenuse. Maybe we should write that down. The longest side, the hypotenuse. Hypotenuse. We're going to solve for the hypotenuse using the Pythagorean theorem. Hypotenuse is always the longest side. It's always across from the right angle, and it's always c. So we're going to solve for c. So we'll do a squared plus b squared is equal to c squared. That's the side that we don't know. Again, A and B are interchangeable. A could be 6, B could be 6. It doesn't matter. It's going to work out the same either way. So I'm going to do 6 squared here plus 8 squared is going to equal C squared. 6 squared is 6 times 6 is 36. 8 squared is 8 times 8 is 64. Is equal to C squared. And 36 plus 64 is going to be 100. That is equal to c squared, but I don't want to know what the hypotenuse squared is. I want to know what the hypotenuse is. So we're going to square root both sides and get 10 is equal to c. Our hypotenuse here is going to be 10 units long. 10 units long. And that, my lovely people, is the Pythagorean theorem. Now, let's take a look at the distance formula. I need a new page because I wrote so giant, took up all my space. Distance formula. The distance formula is D is equal to the square root of, draw a long square root because it's a long bit of information here. We're going to do parentheses x2 minus x1 squared plus parentheses y2 minus y1 squared. I didn't even make it long enough. There we go, because we're going to square root the whole thing at the very, very end. Now these x1s, x2s, y1, y2, those are relating to 2 points. So we're going to find the distance between 2 points. So I need to give you 2 points. Let's say we've got a point at, actually, you know what, let's draw ourselves a little graph so we can see where the points are going to be for this example. Alright, draw a quick little graph. Let's go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. Let's do a point at 3, 1, 3, 1. And let's do a point at -1, -2, -1, -2. And we're going to find the distance between those 2 points. So we're searching for how long that line segment is. How long is that D? Okay, just like I said in the Pythagorean theorem, it didn't matter which one was A and B. In this case, it doesn't matter which point is the first point and which point is the second point. I do have a personal preference. When I'm subtracting something, I like the first number to be bigger. So I'm going to say, let's do this guy here as our second point, our x2, y2, and let's make this one here our x1, y1. So I'm going to label those right now. Let's see if this utensil works. It does. So this will be x1, y1. This is going to be x2, y2. And it's time, scholars, to do some plugging and chugging. Our distance formula, as we just wrote out before, is quantity x2 minus x1 squared plus quantity y2 minus y1 squared, and we'll plug in our numbers, and we'll have x2 was 3 minus -1, 3 minus -1 squared, plus y2 is 1 minus -2, and square it. What happens when we have 2 minuses next to each other? That is correct. They change to a plus, change to a plus. So now we've got 3 plus 1, well that is 4 squared, plus 1 plus 2, that is 3 squared. Square rooting those. There we go. Great. Let's keep going. 4 squared is 4 times 4 is 16, plus 3 squared is 3 times 3 is 9. Getting closer. Got it. 16 plus 9 is 25. And then, of course, the square root of 25 is 5. The distance here we were looking for, whoops, there you go, is 5. I have a very strong preference for the Pythagorean theorem over the distance formula, and I'm going to show you how those two relate to each other. So, we said, let me back up right quick, that the Pythagorean theorem is true for right triangles. Right triangles with a right angle. So, we can take any segment, and turn it into a right triangle. Okay, so I'm going to drop a straight line down, and a straight line across, et voila! I now have a right triangle, and I can count how long these sides are. This was 1, 2, 3 units long. This is 1, 2, 3, 4 units long. Okay, so if I wanted to use the Pythagorean theorem on this triangle that I've drawn, which I will do on my paper here, we'll just say the Pythagorean way. Give me an A in there. I'm going to redraw that triangle. It had a 3, it had a 4, and then there was my right angle. I'm looking for the what? The hypotenuse. C. Great. So we're doing a squared plus b squared is equal to c squared. Again, it doesn't matter which is a and b because we're adding these things together, and you can add stuff in either order. So let's do 3 for a plus 4 for b. It's going to equal c squared. 3 squared is 9, 4 squared is 16. Hey, look. Look at that right there. Oh, yep. C squared. 9 plus 16 is 25, is c squared, and then we square root both sides to get 5. The distance, aka the hypotenuse of the right triangle, is 5. You can use both of these methods. If you have a preference for the distance formula, go for it. Use the distance formula. If you like the Pythagorean theorem, make yourself a right triangle and use the Pythagorean theorem. Excellent. All right, one last thing I want to talk about is simplifying radicals. So far, all of our answers have been nice whole numbers. That won't always be the case. So let's talk about simplifying radicals. There we go. Paper is centered. Simplifying radicals. Simplifying radicals. All right, so let's say we get down to the end of our problem, and we have something that says, let's do, so blah, blah, blah. We did the Pythagorean theorem. We got down to c squared is equal to 120. Now, for those of you that are quick with your perfect squares, you know 120, if you square root it, it's not a whole number. Not a whole number. So let's talk about how to break down said radical. Okay, what we're looking for are numbers we can pull out of the radical, and we pull numbers out of the radical when we have two factors that are the same. This will make more sense after I've gone through this example. So we're going to break this number down, this 120 number down, and any two numbers you can think of that multiply to be 120. I see this ends in a 0, so it must be a multiple of 10. And 10 times 12, that's 120. Okay, great. Can we break down 10? Yes, we can. Into 2 and 5. When I have broken down a number, I like to cross it off, so I know that's not a factor I'm looking for here. And then 12 we can break down into, let's do 4 and 3. Boom. 4 we can keep going with. We got 2 and 2. Okay, so these are the prime factors of 120. We cannot break these numbers down anymore. All right, we are looking for pairs, not triples. We're looking for pairs. So these 2's are a pair. When you have a pair, you come outside of the radical as 1. So we've got a 2 on the outside from these suckers. And the rest of these do not have pairs, so they're going to be stuck inside the radical. So we'll have 2 times 5 times 3. All of those will be inside the radical. So our final answer is going to be 2. Square root of 2 times 5 is 10. 10 times 3 is 30. So our final answer here, if we were using the Pythagorean theorem and have gotten down to where we're looking for the answer to C, we would say C is equal to 2 square root of 30. Okay, great. Let's recap what we talked about. We did the Pythagorean theorem and distance formula. Pythagorean theorem works for right triangles. A squared plus b squared is c squared. That c is your hypotenuse. It's the longest side always. It's always across from the right angle. It does not matter what you put for a and b. Those are interchangeable. All right. A squared plus b squared equals c squared. Work through this. Make sure you square root both sides. Et voila. Then we talked about, nope, not that one. We talked about this one. The distance formula next. Distance formula is d is equal to the square root of quantity x squared minus x2 minus x1 squared plus quantity y2 minus y1 squared. I gave you 2 points. We decided that the point with the larger numbers was the second point. It won't matter. It won't matter if you've done these in the opposite direction. It was just a personal preference for me to have the bigger number be the second number because we're doing subtraction here. I like to do big minus small. Plugged in our numbers, got down to an answer, and then I showed you how you could make this distance formula question into a Pythagorean theorem question by drawing a right triangle and counting how long the sides are. And we got the same answer. So both of these are valid ways to solve these types of questions. And then we talked about simplifying radicals if you get to a point where when you take the square root, it's not a perfect square number. So we broke down the number under the square root into its prime factors, which were 2 and 5 and 2, 2, 3. Looked for pairs. If it was a pair, I circled it, and it came outside the square root. Everybody else is stuck inside the square root. Those numbers get multiplied back together, and that's our final answer. Nicely done, scholars. Keep up the good work. Keep up that hustle. Love you so much. I'll see you next time.